So methane is normally sp3 hybridized. Alkanes are sp3 hybridized.
The strongest acid known ever in the world is fluoroantimonic acid. Please go and learn the types of strong acids and weak acids.
Hi, welcome back again. And if you're new here, this is Tutor Enoch. And today we're going to be looking at some questions that came out in the UCME 2026 examination. And this is the one questions, and these are questions from several batches: 7 a.m., 9 a.m., 11 a.m., and the likes. So we're going to be taking a deep dive into these questions, not necessarily because they would repeat them, but just to learn the pattern in which UTME is asking questions this year and apply it for those or to those who are going to be writing their exams in subsequent days. All right, so let's get in. X plus Y given us Z is an equilibrium reaction. The addition of catalyst will do what? Okay, so we all know that there are some factors that affect the rate of a chemical reaction. What are they? Temperature, pressure, concentration. They affect the rate of chemical reaction, and even catalysts affect the rate of chemical reaction. But when we talk about equilibrium reactions, catalyst does not affect equilibrium reactions. They only affect the rate at which that equilibrium is attained. But when it's already in equilibrium, it doesn't affect it. So let's look at the answer that best fits. So A says increase the amount of Z produced in a given time. No, that's like favoring one side. So when it's already in equilibrium, no specific side is favored. So we want to look for the answer that talks about all sides attaining equilibrium together. B says increases the rate of change in concentration of X, Y, and Z. Okay, come back to that. C says increases the concentration of disappearance of. No, that's still favoring one side. This says increases the rate of forward reaction. That is still favoring one side. Decreases the amount of. So the correct answer is option B here, and this depicts what I said. This depicts what I said earlier by saying that it helps the reaction attain equilibrium, that is, increases the rate of change in the concentrations so that this reaction can attain equilibrium. So the second question is a solution on Faraday's law of electrolysis. So let's look at some things as it pertains to Faraday's law of electrolysis. So we know the first law that says that in order to calculate the mass of substance deposited, right? So there's a formula I use. So the mass I use as small letter m of substance deposited is equals to AIT over what? Over EF. AIT over EF. So the formula I use is mass of substance deposited is equals to AIT over EF. So that's for the first law. Now for the second law of Faraday, there's another formula that says that the mole of substance deposited when a particular quantity of electricity is passed through two different electrolytes, the mole of substance deposited is directly proportional to the charge of that substance. So it's inversely proportional rather. So we have N1 over N2 is equals to, so inversely that will be what? Is equals to C2 over what? Over C1. So where your mole is mass over molar mass. So these are the two formulas that you should always know in your head. In the AIT over EF, M means mass, A means atomic mass, I means current, T means time. I and T can be substituted for Q, which is quantity of electricity, and it is measured in coulombs. YF means Faradays, which is 96,500 coulombs. Then E is the charge of. So you can write E as charge, and we can also write C as charge, or charge as C or E. You can also call it the oxidation state. For example, the charge of oxygen would be 2 minus. The charge of sodium will be 1. But we don't write the minus or the plus, we just write the numbers, right? So those are the things that you need to know when solving questions here. Moving on, the electrolysis of brine gives. So brine is sodium chloride solution, and it's not just sodium chloride solution, it is concentrated sodium chloride solution. That's why if you are lost in the sea for days, you can't drink the sea water because it's so concentrated, even though it's full of water, but you can't drink it because it's so concentrated. So now, if you are electrolyzing concentrated sodium chloride, what will be your product? So the first thing is, what will go to the cathode? Then what will go to the anode? That's the first questions you must first ask yourself. So sodium chloride is in water, right? So we have a solution. So the cations in this solution, which are the positive ions, are what? They are Na plus and what? And H plus. Then the anions in this solution are what? Are Cl minus and what? And OH minus. So these are the cations and these are the anions. So now, after you have gotten this, the both of them would move to the cathode, and the both of them here will also move to the anode. But there's something they call preferential discharge. So in the law of preferential discharge, there's the first law of position in electrochemical series. So when we understand the position in electrochemical series, the hard and fast rule says that we should pick the one that is the lower in that is lower in the electrochemical series. So in the electrochemical series, you have um popular science. The common mnemonic is popular scientists can make it. If you use that, all right. So, but if you check the electrochemical series, which you should be able to see on your screen right now, you see that hydrogen is lower in the electrochemical series than sodium. There's a reason for that, but I'll not be explaining it here. So that means that in the cathode, hydrogen will be preferentially discharged, and in the anode, so in the anode, remember we're treating concentrated. The law of concentration would have applied for the cathode if the spaces between the two ions are not so much. So the law of concentration is the second law, and it says that the one that is the most concentrated is one that will get preferentially discharged. But we also have to look at the position. If the position between the two ions is greater than 3 gaps, the one that is below would still automatically be preferentially discharged. But if it is less than 3 gaps, 2 to 3 gaps, the one that is above, or the most concentrated one, not necessarily the one that is above, is the one that will what? That will get discharged. So for the electrochemical series for the anions, we have for some new common boys in the Olympics. That's the acronym I use, right? So you see that chlorine, the gap between chlorine and common and Olympics is just about 2 gaps. So that means that concentration will work here. So that means that since concentrated sodium chloride is what we're looking at, so that means chlorine is concentrated than OH in this solution. So that means chlorine will be what is deposited at the anode. So that makes this correct. So it's very, very simple. The neutralization reaction is a reaction of an acid and a base to give what? Salt and water. Now, what is the primary product of neutralization reaction? So the primary product is what? Some people may think it's salt, but it's actually water. Because when you look at the ionization reaction, you notice that an hydrogen is coming from the acid and an OH usually is coming from the base. So the main product there is the H2O. So now let's move to organic chemistry. The questions that we asked in organic chemistry. Incomplete oxidation of ethanol yields. So there are some stages in the oxidation of ethanol. So let's look at them. When you oxidize ethanol, and what do you use to oxidize it? If you use a weak oxidizing agent, it will give you what? Ethanol. Boivy ethanol. And ethanol is a family of what? Alkanals. But if you use a strong oxidizing agent to give you ethanoic acid. Ethanoic acid. And the oxidizing agent that usually used here is K2Cr2O7. And what is the IUPAC name for this? The IUPAC name for this, yes, inorganic compounds also have IUPAC name. The IUPAC name for this is potassium heptaoxodichromate 6. All right. So incomplete oxidation, we give what? We end it at this second stage. While complete oxidation, what? Will make it go towards the ethanoic stage. That's the final stage. A question says ethyl ethanoate would react with ammonia to form hydrogen reacts with chlorine to form hydrogen chloride under what condition? All right, so please take note that this happens under ultraviolet rays, but reaction between hydrogen and fluorine can even happen in the dark because how reactive fluorine is. Fluorine, in fact, is the most electronegative element on the planet, while the most electropositive element is cesium, right? Or sometimes we'll tell you francium, but most times we consider it as cesium. But 8, guys, this question is so simple. Orbitals that overlap in methane are, so you'll be seeing a diagram on your screen right now. So methane is normally sp3 hybridized. Alkanes are sp3 hybridized. That is, the carbon atoms is what is sp3 hybridized. And what is hybridization? Hybridization is the mixing of different orbitals to form a single hybrid orbital. So the carbon atom in methane is one that is sp3 hybridized, so it overlaps with the s orbital in hydrogen. So with each s orbital, it forms an overlap. So sp3 hybridized carbon atoms forms 4 overlaps with the s orbital of the different what 4 hydrogen atoms. That is why the sp3 hybrid orbital has like looks like it has 4 different wings. So the number 10 says the oxides that are only soluble in basic oxide is. So the only soluble oxides in basic oxide are what react in basic oxides. And what are those? Those are acidic oxides and amphoteric oxides. So if you notice any option that reacts with that is an acidic oxide or an amphoteric oxide, that would be the answer. Soda lime is used instead of caustic soda because, so this is talking about, this is probably a question about, saponification reaction where esters are reacted with sodium hydroxide to give soap and glycerol, which the main product there is the soap. So you can use caustic soda, but caustic soda is very harsh. That's why we use soda lime. There are forms of sodium hydroxide. Strong acid is, so this is probably a question testing on strong acid. So you can read some things up about strong acid and the examples. The strongest acid known ever in the world is fluoroantimonic acid, right? But some textbook will tell you that it is HClO4. And you should also learn some other properties of strong acids. But 13, water that does not lather easily is what? Is hard water. Extraction of sulfur is what process? Is flash process. So let's look at this refined set of questions now. In the electrolysis of brine, what is produced at the anode? What is produced at the anode is chlorine. We have already looked at why that is. We talked about the effect of concentration. Number 19, which of the following is a strong acid? A strong acid here is an acid that is willing to freely give out its hydrogen ion concentration. Hydrochloric acid is one that is most notable here as strong acids. Please go and learn the types of strong acids and weak acids. The weak acid here is ethanoic acid. So carbonic acid too is a weak acid. But option D, ammonium hydroxide, is a base, not even an acid. Hard water does not lather easily with soap because of it contains, the answer is calcium and magnesium ions. Temporarily hard water contains calcium and magnesium bicarbonate, but permanently hard water usually contains calcium, magnesium, and iron chlorides. So soda lime is preferred to caustic soda because after this it's less corrosive. Hydrogen reacts with chlorine to form hydrogen chloride under ultraviolet light. The process used in extraction of sulfur is flash process. Contact process is used in the production of what? SO3. Haber's process in the production of ammonia. Solvay process in the production of sodium carbonate.
Which oxide is amphoteric? So how you know an amphoteric soft oxide? There is an acronym for it, and it's known as ZOLT. So the acronym ZOLT means Z means zinc, A means aluminium, L means lead, and T means tin. So which of them comes in the options? A, that is aluminium. So that is option C. 26. The product of incomplete oxidation of ethanol is ethanol. For complete oxidation, it will be ethanoic acid. And the oxidizing agent used there is K2Cr2O7, that is potassium heptazodichromate 6. 27. Neutralization reaction involves an acid and a base, giving a salt and water. The main products here being water. The electronegativity trend across a period is that it's so electronegativity trend. So electronegativity across a period it increases, but down a group it decreases. So that's why at the left side of the periodic table we have more of electropositive elements, which are the metals, but at the right hand side, um across the period they usually mean from left to right. So please just take note of that. Calcium carbonate reacts with acid to produce. When calcium carbonate reacts with acid, they give three products. They give salt, they give water, and they give carbon dioxide. So that is option C. Number 30, the combination of two or more elements to form compound is called synthesis. Like you're trying to react hydrogen and chlorine to give hydrogen chloride. That's hydrogen chloride synthesis. Number 31, the general formula of an alkyne. Each of these elements have their own formulas. Alkanes have the formula CnH2n plus 2. Alkenes CnH2n, alkynes CnH2n minus 2. Aromatic compounds have their formula to be CnH2n minus 6. So please take note of that. 32 says if the vapor density of an alkane is 15, then what is its molecular formula? So there's this formula that says relative molecular formula is equals to vapor density times 2. RMM is equals to VD times 2. So just multiply that by 2 and you will get your answer to be 30. So the last question is the question on electrolysis. So you have seen the questions that are very prominent here. You can see that electrolysis was tested here. You can see that a lot on acid, base, and salt was tested. Your periodic table too as well. Organic chemistry, you can't just do that. Saying that you can't escape it. Your water. So if they test on water, they might want to test on air on day 2. So this is the questions that were set for chemistry. So please make sure you revise these topics tonight so that if you're writing an exam tomorrow or any other day, you can be very much prepared. Bye.